Okay, so now we come to the second part of the video. Okay, so in this part of the video we are going to discuss the last section of chapter 4, which is Fourier transform and inverse. Okay, so if you're aware, this chapter 4 ni, which is Fourier analysis, consists of actually two parts. Okay, where the first part is on the Fourier analysis and on the Fourier series, and the second part, here we are, which is Fourier transform and also its inverse. So in comparison to Fourier series, Fourier transform ni saya tak adalah will go into very detail. I just have two examples to discuss with you. Okay, because kalau compare dengan Fourier series, kalau compare dengan Fourier series ni, for me is more important for your course right now, because in the coming chapter 5, kita akan guna balik Fourier series but not Fourier transform. But nevertheless doesn't mean that Fourier transform ni tak important. In fact, Fourier transform ni pun sama penting, but not for this course, for other courses that you are going to learn in future. So meaning to say, in other subjects you are going to learn again Fourier transform, and there are actually bukan hanya what we are going to discuss right now, but there are some other things about Fourier transform. So untuk hari ni, my learning objective or learning outcome is just to make sure you understand sahaja apa maksud Fourier transform tu. Okay, we are not going to go into details on how does we do the Fourier transform secara spesifik lah. Okay, because in other subjects you are going to learn much more details. Okay, for example, untuk electronic and instrumentation students, ada subjek signal and system. Okay, and I'm sure for technology maritime students pun ada subjek yang you akan jumpa Fourier transform ni, if not for the core subject, in other elective subjects. Okay, so now we go straight. Apa maksud Fourier transform ni? Fourier ni, we have discussed about Fourier series before, but we are not yet discussed about Fourier transform. So Fourier transform, for every function sebelum ni, for every function of fx, we have its Fourier series. But now we are going to, for every function of fx, we are going to find its Fourier transform. So apa maksud Fourier transform ni? We have a function fx, and when you transform it, okay, we use this symbol f macam ni, okay, we will get the function in omega, indicate that we have transformed it into using Fourier transform. Okay, Fourier transform ni adalah actually one kind of transform that you are going to change from the x domain ataupun t domain. X ni space kan, t ni time domain, into omega. Apa itu omega? Omega is 2 pi f. We have discussed about this, which is frequency domain. You may consider this as frequency domains. Kenapa frequency? Because omega kan sama dengan 2 pi f. We have discussed this, okay, in last week during my synchronous lecture. I do introduce to you omega is equals to 2 pi over omega is equals to period. Am I right? Okay, because 2 pi omega is 2 pi f, so you have 1 over f is equals to p. Okay, so clear, Fourier transform is used to transform from time or a space domain into frequency domain. So dia punya formula, dia ada dua formula ni. First is to find its Fourier transform. So dia punya formula adalah, this is actually conventional method, sama juga dengan Laplace. Remember beginning of chapter 3 when I want to introduce to you Laplace transform, okay, for a function ft, then dia punya conventional method dia is you to integrate from negative infinity to infinity ft e to the power of minus st dt. Remember? Okay, so this is for Laplace. So for for the Fourier pula, okay, Fourier F lah pula, okay, F of fx, which will give you f omega ni, dia punya formula is equals to 1 over square root of 2 pi integration from negative infinity to infinity fx, the function given to you that you want to change it into f omega, then multiply with e to the power of minus I omega x, and you are to integrate respect to dx. Okay, and this is pula dia punya inverse. Apa maksud inverse? Maksudnya kita punya function now is dalam bentuk full frequency domain. Okay, frequency domain, and we want to get back to the time or to the space ataupun time domain. So how we're going to do this? Then we are going to use the Fourier inverse Fourier transform. So macam mana nak buat inverse of Fourier transform ni? Okay, inverse of Fourier transform of f omega is equals to fx. Nah, so beza dia dengan yang atas ni hanyalah sign ni je, negatif, yang ni jadi positif, I omega x. But then careful lah, function is no more fx. Kalau nak find inverse, of course kita asal daripada frequency domain, so maknanya daripada f omega e the power of I omega x d omega. So we are to integrate respect to omega ataupun 2 pi f lah. Tak payahlah tukar pada 2 pi, just remain as 2 omega kat situ. Okay, so 1 over square root of 2 pi. Alright. Okay, so now we proceed with example 7 here. Okay, this example 7 asks you to find the Fourier transform of fx given fx is equals to 1. Okay, if for the domain modulus x less than 1, modulus x less than 1. Saya rasa you all pun pernah belajar dulu dalam model maths ke matrix ke mana-mana lah. Okay, this modulus x you can evaluate it as x less than 1 greater than negative 1. So basically you nak carinya the Fourier transform. If you sketch the graph fx here, we have fx equals to 1. So maknanya a horizontal line which expands from x equals to negative 1 to 1. So kita nak cari, okay, macam ni fx kita. Okay, we want to find the curve horizontal line ni dalam frequency domain. So remember just now dia punya formula for Fourier transform, the general formula is 1 over square root 2 pi from negative infinity to infinity. Tapi since the interval here is from negative 1 to 1 sahaja, so that's why here the integration, okay, range from negative 1 to 1. And then dia punya standard formula kan, negative infinity to infinity fx e power of negative I omega x dx, right? But as you can see here, we just have e to the power of minus I omega x respect to dx. So what is our fx? As what we given here, fx is just equals to 1. So maknanya fx ada kat sini, tapi it's just 1. So darab dengan e power of negative I omega x. So bear in mind, to integrate an exponential function, we get back the exponential function, then divide by the derivative of the power here, so negative I omega. Okay, I ni apa sebenarnya? Okay, I forgot to introduce to you. I ni samalah dengan imaginate equals to negative 1. Okay, or sometimes we use j, same thing. Okay, and then bila kita ganti with x equals to 1 and negative 1, so this is what we get. Okay, ni apa yang kita dapat lah. Which is e to the power of negative I omega minus with e to the power of I omega. And then from here, okay, daripada sini, kalau you ingat last week kan, I ada upload dekat Google Classroom Okay, list of important properties transform table dan juga trigonometric identities. Dalam tu kita ada benda ni, what we call this as a Euler Formula. Okay, Euler Formula where e the power of I omega equals to cos omega plus with I sin omega. Kalau negatif pula dia jadi minus sin omega. So what we have over here, kan, kita ada e the power of negative I omega. So I e the power of negative I omega, negative I omega tolak dengan e the power of I omega is going to be equals to cos omega tolak I sin omega minus with cos omega tambah dengan I sin omega, right? So daripada sini we have cos omega minus I sin omega tolak cos omega minus with I sin omega. So this one and this one cancel. We have negative 2I sin omega. Okay. So daripada sini, kan, maknanya yang ni adalah equals to negative 2I sin omega. So we have I over negative I omega square root 2 pi tolak 2I sin omega. Then this negative you may cancel. I dan I here you cancel. So we left with 2 sin omega over omega square root 2 pi. Dan kita tahu 2 ni adalah, okay, 2 ni adalah square root 2 darab dengan square root 2, kan. So square root 2 pi pula square root 2 darab square root pi omega, okay, sin omega. So you may cancel this. Then we have finally square root 2 over pi sin omega over omega. Ni dah jawapan akhir kita. Oops. Cuba you check kat sini. Okay. Let's check. The answer given here macam terbalik, kan? What we have here is square root of pi over 2 sin omega over omega ni dah betul. Tapi yang here kita ada square root pi over 2. But over here is 2 over pi. Terbalik ni. So you reckon which one is correct? Ataupun there is a way that to make it each of this become sama? Setahu saya dua benda yang berbeza kat sini. Okay, we have here f omega equals to this answer given by our workout here. Okay, our workout is square root 2 over pi. So how we going to check siapa yang betul sekarang ni? Kat mana ni ada judge tak nak decide siapa yang betul? Okay, let's have a look at the table here. Okay, for Fourier transform sama juga dengan Laplace. Actually, the exercise or the formula that we have is so called as a conventional method. You can actually straight away grab the transform by referring to this Fourier transform table. Okay, so kalau you tengok number 1 ni, the function is fx equals to 1. Sama dah dengan kita tadi. Kita kan tadi fx equals to 1 for x in between 1 and negative 1. Otherwise is 0. Okay, so for our case kat sini maknanya our b kat sini is equals to 1 lah. B equals to 1, so x less than 1 greater than negative 1. See what we have here. When b equals to 1, so the answer, the Fourier transform is going to be square root 2 over pi sin omega over omega. So siapakah yang berada di landasan yang betul sekarang? Saya ke jawapan yang diberi? Seems that saya lah, kan? Square root 2 over pi is the correct answer. So please class, sorry I didn't notice there is a typo error here, so please make correction dekat notes. This is supposed to be square root 2 over pi, bukan pi over 2. Okay, clear everyone? Okay, now let us proceed to the next example here. Example 8. Example 8 ni, find the Fourier transform of, okay, this is the notation for the Fourier transform. This is to find the Fourier transform. This one is to find the inverse of Fourier transform. Kalau Laplace macam mana? Laplace macam ni. Okay, this is to find the Laplace. This is the Laplace transform, right? Okay, so given here, meaning kita nak cari the Fourier transform of fx equals to e to the power of negative ax. For what range? For if x more than 0. More than 0 meaning integration from 0 to infinity here. Fx equals to 0 if x less than 0. Maknanya from negative infinity to 0, our fx is 0 and multiply dengan e to the power of negative I omega x with respect to dx. But why we need to integrate? Sedangkan jawapan dia kosong, so just leave it. So we have here 1 over square root 2 pi integration from 0 to infinity negative e to the power of negative ax darab dengan e to the power of minus I omega x dx. So since we have same base, then you can add up the power together, and since we have a common common variable x here, so you may factor out x. So we have negative a plus I omega, and remember when you want to integrate kan, we copy back the soalan tu, we divide by the derivative of the power, which is a plus with I omega. So yang ni kalau you gantikan square root 2 pi negatif ni, letaklah kat depan negatif a plus I omega ni dah memang sah, nothing to do with x. So you just gantikan dengan e power of negative a plus with I omega darab dengan infinity minus with e the power of everything 0 lah. Something that darab dengan 0, everything will be 0. So yang ni definitely equals to 1. Yang ni pula ni kan negatif, so maknanya dia adalah 1 over e to the power of whatever it is inside here, multiply dengan infinity, it will be infinity, so will approach 0. So this part will be 0. So kosong tolak 1, so this negative we cancel with this negative, so dapatlah jawapan kita 1 over square root 2 pi a plus with I omega, sama dengan jawapan yang kita ada kat sini. And then if you refer to the Fourier Transform table, cuba tengok nombor 5 ni. Yes, exactly apa yang kita derive tadi or integrate tadi. We've gotten the answer same as what is listed dekat Fourier Transform table, which is 1 over square root 2 pi a plus with I omega. Alright class, so we come to the end of chapter 4. Kalau you notice for Fourier inverse saya tak bagi example pun, but because for the coming chapters kita tak guna pun for Fourier inverse ni, okay, but you may find it, or you are going to learn that in other courses as I said before. Alright, so with this we have completed chapter 4. Okay, and as Fourier transform ni bukan kata tak penting. If you notice dalam soalan assignment, there is one question kan, the last question I ask you to find the Fourier transform of a function. Okay, but it is not as important as Fourier series lah. Alright, so with this we have completed chapter 4. So you please make sure all of you understand everything has been covered for this chapter 4, and do not forget to solve the classwork submission and submit by tomorrow tonight. Okay, and doing the assignment, and remember also next week Monday is your second test. Okay, your second test, and this chapter 4 will be part of the coverage for your test 2 together with chapter 3. Okay, Laplace transform. Alright class, so that's all for today. Anything you can always text me dekat WhatsApp. Till then, thank you very much and bye bye.